Hello everyone, my name is Kalei Lopez and I'm going to be showing you how to do number 6 from the Diffraction Gratings section of Optics for Spectroscopy. This question is in reference to an article titled Near Infrared Spectroscopy by Baker et al. And this article describes how near infrared spectroscopy is conducted using wavelengths around the iso-B stick point for hemoglobin, which occurs at a wavelength of 800 nanometers. It's also important to note that the iso-B stick point is the wavelength at which both hemoglobin and oxygenized hemoglobin have the same extinction coefficient. And this question is, the next problem looks at NIRS measurements taken on tissue. The two wavelengths of light use a 700 nanometer and 900 nanometer length. Assume that both wavelengths are reflected off the tissue before being sent through a diffraction grating with n equals 2500 lines per centimeter, so the intensity of each wavelength is analyzed separately. What is the angular location of the third peak of 900 nanometer light? N equals 3. So these are all the values we were given. We were given m, which denotes the order, equaling 3. We have n, 2500 lines over centimeters, and the wavelength 900 nanometers, and we're looking for the angular separation. So we're going to begin by using this equation of the slit spacing equals 1 over n, and we just input these values. We end up with the slit spacing equaling 4 to the negative 4th centimeters. And then we're going to be using this final equation, d sine theta equals m lambda. And we're just going to rearrange it so that we can find theta. And we have all these values now. We're going to input the values, and we end up with theta equaling 42.45 degrees. That is the angular separation equaling 42.45 degrees. And that's the answer. Thank you.